Welcome, geometry students. For our video today, we will be talking about the language of geometry and working on learning vocabulary and notation so that we can all be speaking and reading the same language together this year. So you will need your in class 1 BL, that's for blended, to follow along. Please make sure that you take notes, mark anything that you have questions about to bring back to class tomorrow and to clarify. We have one line of information already filled in for you on this graphic organizer, and that is the idea of what a point is in geometry. So a point is just going to represent for us a location in space. It actually has no size, so even though this dot that we have as our labeled sketch looks like it has some kind of width and height, a point is really just marking that location. We label points with capitalized letters. Any letter of the alphabet is acceptable, and if you are reading a paragraph and they want to talk about a point or a set of instructions, they will use just that capital letter by itself, or they'll have the word point in front of it with the capital letter. Moving to our next term, a line is actually a term that is undefined in geometry, which means it doesn't officially have a definition like the heading of this column. But it has kind of a description that we all agree that a line represents. And so when we visualize a line, we want to be thinking about a figure that is perfectly straight for the Euclidean geometry that we study. It has no thickness and it extends forever or infinitely, if you want to use that word instead, in two directions. And so if we investigate this labeled sketch a little bit, we can see that happening. There are arrows at both ends of this perfectly straight geometric object. And then along this, we'll notice a few points from that first line in our graphic organizer, labeled with capital letters. And then we have this thing here, which is not a capital letter, and it doesn't have a point next to it. So all of these can be used in different ways to help us name or notate our line. So one option when we're talking about lines is to use two of the points, only two. So you can choose any of the two you want. We might use C and D, kind of the points that look like they're the farthest away from each other. And then you'll notice that once I wrote C and D, I put this little line above the letters. That's how we know when we look at this symbol that it represents this object that's straight, that extends forever in two directions. If we wanted to continue to use point C, we could pair it up with point A, and another name for the line could be CA, line CA. Or if we wanted to continue to use letter D, point D, we could pair it up with A. We could also flip the order of these letters. So instead of calling it line CD, we could call it line DC, or line AC, or line DA. So lots of options, but only two of those points. We would not ever call it line CAD, all three. Now in all of those names, I've avoided this little M here, and that's because that little M is lowercase, which means it's not a point. And so what we use that for is to name with the word line, actually. So if you see any of these fancy or cursive lowercase letters kind of at the tail end, the side of one of these lines before that arrow that shows you it keeps going forever, you can write the word line out and then you can use that fancy or cursive lowercase letter, so M in this case, and another name for the line would be line M. Moving on to row 3, line segments are going to be a part of a line. So we're going to take this figure and do something to it. We're going to create just a part of it. It's going to begin at one point, okay, and end at another. Or sometimes we talk about those beginning and ending points actually as end points, both of them, okay? So in this figure, we can notice that we have a point M, we have a point N, we see the dots, we see the capital letters, we do not see the arrows like we had before, and so it's just a segment, it's just a part of that line. If I did the same thing up here and I covered up this and I just left behind the C and the A, That would be segment CA if I was just focusing in on that portion of that line from before. So to name these, we just take those endpoints and we put them in whatever order we wish. And the symbol doesn't have arrows because it's not extending forever in either direction. It's just in between M and N. Now, if there had been a third point on this line, we would not use that to name the entire line segment. We would just leave it out. If we wanted to name this portion of the line segment, then we would use that letter E. Or if we wanted to name this portion, we would use that letter E. Moving on to the fourth row, we're moving to the idea of a ray. So a ray is also going to be a part of a line, but the difference is that a ray starts at one point, but then does extend infinitely or forever in only one direction versus the line that extends in two directions. So if we investigate our diagram here, our labeled sketch, we can tell that this ray is starting at point S, and then it's extending forever in this direction because of that arrow at the end, past letter T. When we name a ray, we must show where the ray begins first. So any name for this ray is going to start with the letter S because that's the starting point for that ray. And then we choose any other point along the path of the ray to finish out the name. We don't use all of the points along the path, we just pick any other point. So ray SR would work. And if we're thinking logically, when it was a line, we drew a little line. When it's a segment, we draw a little segment. So when it's a ray, we're drawing a little ray. Now you might notice that this ray is pointing kind of left and down, but this ray is pointing directly to the right. Our symbol, when we use notation, always looks like this, no matter what direction the actual object is pointing. So it's always going to point directly to the right when we write the name of a ray. Another option for this ray, think if you can come up with it. We have to still start with S, remember, because that's where the ray begins. But then instead of talking about how it passes through point R, it also passes through point T. So we can call this ray ST as well. All right, two more on the front side of our notes for today. An angle. So an angle is very different than the ones that we've covered so far. An angle is a whole figure, so there's more going on with an angle than there is in the others. So let's talk about what that figure is formed by. We're going to have a figure that's formed by two rays. So think in your mind what we just said about rays. And those two rays must have a common endpoint. And we actually give that common endpoint a special name. It is called the vertex of the angle. Okay? So what we have is a situation where we have ray number 1 that starts at B and extends forever this direction. Ray number 2 that also starts at B, making it a common endpoint and extends forever this direction. The angle is this figure. And so it has some kind of measure depending on how far we must rotate to get from one of those rays to the other. So when we start measuring and working with angles and solving problems about angles, we're describing this space that's inside when we measure them, this rotation that takes us from one ray to the other. This point B right here is going to be that vertex, that common endpoint. And in this case, because there's only one angle possible, that's an acceptable way to name it. We make a little angle symbol out front, and then we use that vertex, that common endpoint letter. In some cases, that won't work because there will be like multiple angles stacked up, kind of sharing rays in common. We'll see some complicated pictures later. And so in most cases, we actually use 3 letters to name an angle. So go ahead and add a C next to that point on that topmost ray and an A next to that point on the bottommost ray. And we make sure that the vertex, that common endpoint, is always the middle letter. So we could call this angle ABC. That would be like we were traveling the angle's boundary this way. Or we can flip that around. We can use our angle symbol still, but we could start with the C, then travel to the vertex B, and then finish it out by traveling to that other, or along that other ray through A. So angle CBA. Last one for the front side. Plane is another undefined term in geometry, and we're not talking about like an airplane that you fly from here to somewhere on, but we're talking about a figure that extends infinitely in all directions along a flat surface, and it has no thickness. So you could visualize it like an infinitely big sheet of paper. And this is what we draw when we draw a plane. We always draw it kind of slanty, looking like a parallelogram. Planes can have points living on the inside of them. It looks like 3 of our points are labeled with capital N, capital O, capital P. So let's put a capital M right here next to that one that didn't have a letter. And then they sometimes have these fancy or cursive capital letters, like our lines before had fancy or cursive lowercase letters. And so what we can do to name a plane is we can use any 3 points that kind of make a triangular area. So they're not going to all line up on the same ray, segment, or line. They have to kind of make a triangular area because then that extends out to create that whole flat surface. So we could use M, N, and O. M, N, O, just 3 letters all slid together. We could use P, O, and M. And there are lots of other combinations of 3 that would kind of make a triangular figure that then would extend out flat to create that whole flat surface. The other option is if you have this fancy capital, cursive, uppercase letter, you can write the word plane out like we did with the word line, and then you can use that fancy letter. Let's see how well I can draw this fancy R. Just do your best to match whatever is there. And those are usually hiding in one of the corners of the plane, and they won't have that dot next to them to show that they're not points. All right, go ahead and flip to the other side of your sheet. All right, we have 6 more words on this side of the sheet, but hopefully now that we have some of the basics down, we'll be able to move a little bit faster through these as they kind of just describe different relationships. Collinear is the first one. Co, like cooperate, you work with somebody. So collinear is going to be a description of a set of 3 or more points. We're talking about points when we're talking about collinear, which are contained by a single line. So it's 3 or more points that live together on the same line. That's what we see here. We see exactly 3. So there's not a symbol for collinear. We would just list those 3 points out as a list, but it is important that you put commas between them, because if you didn't, it would try to look like it was naming a plane. 3 letters all smashed together. So make sure we're listing collinear points like a list, like you would in English, with commas in between them. So point C, point A, and point D are collinear. Non-collinear is the opposite. So this is the description for a set of at least 3 points again, but this time they are not contained by a single line. It's okay for 2 of them to be on the same line. So it's okay for C and A and D to be options for collinear, but we can't pick all 3 of those. We can pick any 2 we want. So we could pick A and D, but then we would have to make sure that our choice for the 3rd point was off of the line, like letter Q. So it could be A, Q, and D, or it could be C, Q, and D, or it could be C, A, and Q. Lots of options. 2 are acceptable to be living on the line, but at least one of them needs to be off of that line for non-collinear. The idea of between is going to be important as we move into Standard 1 here in a few days. So between in math describes a point that lies on a line connecting 2 points, and it has one of the points on each side of it. There are some situations in geometry that are really difficult to describe in words, so if you're like, what did that mean? The picture is really all you need for the idea of between. This point right here that does not have a label, we can tell what it's supposed to be by the answer over here. That is the point which is between the other two. Now there's something really important to know about between. Your brain is going to play a trick on you and it's going to think that between needs to be directly in the middle. So we purposely drew that to try to keep your brain from doing that. Between does not mean middle. There's a different word for that. Between just means that it's anywhere along that line in between other points. So point R for this picture is the one that's between the others. We'll also be talking about measurements. Distance is what we talk about when we're talking about lines. So distance is going to be a measurement from one point on a line to another. So in this picture, if we want to talk about this measurement here, we could get out our ruler potentially, and we could figure out what it is. We're just going to pretend like it's 1 inch. Okay, and so if we were talking about the measurement, the distance between A and B, we're going to use those 2 points, those 2 letters, but we're not going to put that segment bar above it. We're just going to leave it blank up there. And so that's the geometry way of talking about distance. The place where you start measuring, the place where you stop measuring, and then we don't put any symbol up there to indicate that it's distance. 2 more, which are very similar to the 2 that we started with, except we replace linear with planar. So, coplanar. That's going to be that's going to be a description for a set of 4 or more points which are contained by a single plane this time instead of a single line. So when we look at this picture, that's exactly what we have. We have point N, point M, point O, and point P that are all contained by that single plane. Again, put your commas there so it looks like a list. And then last but not least, non-coplanar. That's going to be a description for a set of at least 4 points which are not contained by a single plane. And so kind of like with collinear, it's okay if some of the points are on the same plane, like P and N and M or O, for example. Those are all on the same plane, but then we have to make sure we include a point that is off the plane. And this is how we indicate something is moving off of that flat surface. That line drawn in this picture intersects the plane at N, touches the plane, and then it goes through it and gets hidden for a while. That's what that dashed line is, and comes shooting out the bottom. And so S is a point that's hovering above that flat surface. So as long as we include S in our list with those other 3 that were on the plane, then we know we have a set of 4 points that are not all contained by the single plane. All right, that's it for today. Bring those notes back with you tomorrow, and we will double check your understanding and make sure we are ready to speak the same language all year together. Thanks for watching.